issues. All right, welcome to day 8. Today we're going to continue the learning journey of Kubernetes. Over the last week, rather, we spent time to understand Kubernetes, and this week we're going to dive into the actual practical. I actually discovered that this topic here, okay, this title here, if it refers to this page, okay, if you go to this page here, Hello Minikube, okay, is simply this title here. Hello Minikube is this one, okay. Then this other one here, which says walk through the basics, is referring to another page, which is this one, okay. But let me explain. Let me open this, okay? Before we start, I want to show you something. So you see, this is Hello Minikube, okay? But if you go open this page saying walk through the basics, it brings you to a page, okay, with a number of steps, okay, things to learn. When you click on create a Kubernetes cluster, okay, it goes on at the end, okay, to lead us to this Hello Minikube page. So I think the best thing to do is to start with this, okay? Then we go to this other one here of Hello Minikube, okay? So I discovered that by just skimming through the documentation. So I think it's a good thing for us to do. And I'm very excited that today is when we start doing the practical, okay? And do something cool. So I'm very hopeful for another day of success and learning. Now let me start, okay? I'll start from right here. It's saying using Minikube to create a cluster. Objectives: learn what a Kubernetes cluster is, learn what Minikube is, start a Kubernetes cluster on your computer. That is the goal, okay? And that's what I'm trying to achieve today. So I'll move on to the next topic, which says Kubernetes clusters. It says Kubernetes is a production-grade open source platform that orchestrates the placement, and placement, they mean scheduling and execution of application containers within and across computer clusters. Okay, so it is a production-grade platform, not just in a platform, but it's an open source platform which is responsible for orchestrating, and orchestrating simply means scheduling and executing application containers within and across computer clusters. Okay, so a computer cluster is simply a collection of machines, of computers. So we'll move on, okay, to the next paragraph in a step to create our first cluster. Okay, it says Kubernetes coordinates a highly available cluster of computers that are connected to work as a single unit. Kubernetes coordinates a highly available cluster of computers that are connected to work as a single unit. It then goes on to say the abstractions in Kubernetes allow you to deploy containerized applications to a cluster without tying them specifically to individual machines. The abstractions in Kubernetes allow you to deploy containerized applications to a cluster without tying them specifically to individual machines. Sometimes I love reading something more than once just to make sure I've understood it. Okay, so they're saying Kubernetes helps us to simply deploy containerized applications, because of course it is a container orchestrator, meaning it is responsible for executing applications which run in containers. So it helps us to deploy these applications in containers, okay, to a cluster, or to a cluster simply means a group of machines. Okay, so we have our application. So think of an application like your e-commerce app. Okay, you have an e-commerce application that you've built. Okay, and then this e-commerce application that we have built, okay, we deploy it, okay, to a cluster. Okay. So what does it mean? It means we have our application running and being managed by a collection of computers. Okay. This collection of computers, which are responsible for running this one application or many number of applications, okay, are called a cluster. Okay. So this collection of machines work together. Okay. And these machines have containers running in them, okay? And it's Kubernetes which is responsible for running them, like we have just read. So this is how I understand it. If you understand it otherwise, do not hesitate to let me know. Okay. So they're not tied to specific individual machines, which means they can be swapped around in case one fails, another one can be restarted, okay? And stuff goes on smoothly. So they're saying to make use of this new mode of deployment, applications need to be packaged in a way that decouples them from individual hosts. They need to be containerized. Okay. So containerizing applications decouples, they must separate an application from the individual host. And they're saying, just to read this again, they're saying containerized applications are more flexible and available than in past deployment models. In the first 2 or 3 videos, we looked at the traditional ways of deploying things. Okay, we looked at 3 deployment models. Then they're saying, okay, let's read this again. Containerized applications are more flexible and available than in past deployment models, where applications were installed directly onto specific machines as packages deeply integrated into the host. Okay. And now they're saying Kubernetes automates the distribution. And select this. They're saying Kubernetes automates the distribution and scheduling of application containers across a cluster in a more effective way. So Kubernetes automates, okay, the distribution and scheduling of application containers across a cluster in a more efficient way. We go on to the next part. Says Kubernetes is an open source platform and is production ready. Okay. It is an open source platform and is production ready. This is very, very good to know. So it says a Kubernetes cluster consists of 2 types of resources: the control plane, which is responsible for coordinating the cluster, and nodes are the workers that run applications. Okay. So I hope by the time we've come to the control plane and to the nodes, we understand what a node is and what a control plane is. Okay. We looked at the architecture and the components of Kubernetes in between the first and third stream. Okay. So if you missed out on that, check the link in the description to look at that time when I learned that. Then they have a cluster diagram. Okay. Talking about the control plane, talking about the node process. So these are nodes, okay? And every node has a node process, okay? That's what they call the kubelet. We looked at, we have just the Docker runtime, okay? We are seeing this, and of course, all this makes up the Kubernetes cluster. So the nodes are the individual machines, okay, which are responsible for running the application. Then the control plane coordinates and manages the cluster, okay. And we saw this, so I won't waste time on that, okay. So let's continue. They're saying the control plane is responsible for managing the cluster. Again, we already learned about this in the first 3 videos. They're saying the control plane coordinates all activities in your cluster, such as scheduling applications, maintaining application state, scaling applications, and rolling out new updates. Okay. And we again learned about this within the first 2 videos. Okay. So I'll go on. They're saying the control planes manage the cluster and the nodes that are used to host the running application. Okay. So they're just trying to re-emphasize the whole point. Okay. And yeah, it's quite clear that now we know that the control plane is the one that coordinates the whole system. It manages scheduling, okay, maintaining applications, desired state, okay. It scales applications or scales down and rolls out new updates. Then they talk about the VM, okay, which is the node. They say the node is a VM or a physical computer that serves as a worker machine in a Kubernetes cluster, okay. A physical machine or a virtual machine. So VM is abbreviation for virtual machine, okay, that serves as a worker machine in a Kubernetes cluster. So in simple terms, for me, I would think that a node is simply a machine, okay, which could be a virtual machine or a physical machine. And they're saying each node has a kubelet, which is an agent for managing the node and communicating with the Kubernetes control plane. Again, we learned about this earlier, okay? So they're just repeating to re-emphasize the point. They're saying the node should also have tools for handling container operations, such as container or CRIO. Okay, we learned about this within the past two videos where we learned about the container runtime. Okay, so container is a runtime and CRIO is a container runtime specific for Kubernetes. Then we go on to read, they're saying a Kubernetes cluster that handles production traffic should have a minimum of 3 nodes, because if one node goes down, both an etcd member and a control plane instance are lost and redundancy is compromised. Okay, yeah, so they tell us we must have at least 3 nodes, because if one node goes down, then the etcd member and the control plane instance are lost and redundancy is compromised. So you know, if you remember what etcd is, it's the key value store, okay, for the cluster, and it's found on the control plane. And I think you can mitigate this risk by adding more control plane nodes, okay, which is a good thing, okay, because if one control plane node collapses, then you have another one to manage, okay, the entire cluster, which is good to know. All right, I can't wait to get to the practical. Let's continue reading, okay. I have to exercise some patience. They say when you deploy applications on Kubernetes, you tell the control plane to start the application containers. Okay. The control plane schedules the containers. The control plane schedules the containers to run on the cluster's nodes. Then they're saying the node level components, such as the kubelet, communicate with the control plane using the Kubernetes API. Okay, so remember the Kubernetes API, which is responsible for exposing an HTTP API to enable communication. Okay, so now we are learning that the kubelet, which is responsible for now managing the node, okay, managing the node, okay, is the one which communicates with the control plane. How does it communicate with the control plane? Using the Kubernetes API, okay. And again, you see they say which the control plane exposes, like we discovered earlier. And they're saying end users can also use the Kubernetes API directly with the cluster. Okay, so they're saying a Kubernetes cluster can be deployed on either physical or virtual machines. To get started, okay, I want to select this. To get started with Kubernetes development, you can use Minikube. Okay, now we are getting somewhere. We are getting somewhere. Minikube is a lightweight Kubernetes implementation that creates a VM on your local machine and deploys a simple cluster containing only one node. I'll read this again. To get started with Kubernetes development, you can use Minikube. Minikube is a lightweight Kubernetes implementation that creates a VM on your local machine and deploys a simple cluster containing only one node. Okay, so it creates a virtual machine. Okay, they're saying Minikube is available for Linux, for Mac OS, and Windows systems. Okay, and now they're saying the Minikube CLI, or the Minikube CLI is for command line interface. So the Minikube CLI provides basic bootstrapping operations for working with your cluster, including start, stop, status, and delete. Okay, so we can start the cluster, we can stop it, we can find out the status, or we can delete it. Good to know. All right, so we are done with this. So it's been a very good recap. Okay, so they're saying what's next? they're saying hello Minikube. So when I click hello Minikube, it's going to lead us to this other documentation which I've already opened. Okay, so it doesn't matter. I can now close this one and click next. Okay, so they have actually given us a quick recap. Okay, of what of what to expect. Okay, so let's now go on. Okay, we have not ended, we are continuing. So just before we continue, they talked about the control plane and the node again. Okay, the control plane is responsible for managing the whole cluster. Okay, what is a cluster? A cluster is simply a set of machines. Could be virtual machines or physical machines. These machines work together to handle deployment of your application. Okay, so the control plane ensures that these machines are running. It ensures that they are scheduled properly. It ensures that they are maintained to run at the desired state. Okay, and these machines, okay, are called the nodes. Okay, the nodes have what is called a kubelet. Okay, this kubelet is responsible for managing them. Okay, managing the nodes and for communicating with the control plane. How does the kubelet on the node communicate with the control plane? Using the API server. Okay, the API server is found on the control plane. Okay, so guys, make sure you understand the things the way I'm speaking them out. Okay, so that you can just easily speak them out and say it aloud. Okay, if you haven't watched the previous videos, again, do it as much as you can until you understand it. Okay, that's the goal. The goal is not just for us to read, but to understand. Okay, so also another thing is that this API server does not only help the kubelet communicate with does not help kubelet, which is in the node, to communicate with the control plane, but also it helps us developers or users to communicate with our cluster. Okay, and we've been told that we can what use it to start, stop, check the status, or delete the cluster. Okay, but now to create a cluster, we need a tool like Minikube. Okay, Minikube can help us to create a cluster, okay, a VM on our machine, and have a basic cluster with one node. That is where that is why we are now on this page. Okay, so they're saying hello Minikube, and they say this tutorial shows you how to run a simple app on Kubernetes using Minikube. They're saying the tutorial provides a container image that uses Nginx to echo back all the requests. Okay, so if you don't know what Nginx is, don't worry. Okay, I'll simply give you a simple highlight of what Nginx is. So what we have here next, okay, is the objectives. So I hope you guys are learning and enjoying this. Okay, so, but simply, Nginx is simply an open source web server. Okay, think about Nginx as a web server, which can function like a load balancer, a reverse proxy, a cache, etc. Okay, so if you're learning with me and you're enjoying this, share it with people in your network so that they also benefit from this and we learn together. Okay, so guys, now let's go to the next part. Okay, which is talking about the objectives. They say the first objective is to deploy a sample application to Minikube. Okay, run the app. Why to Minikube? Because Minikube is going to help us have that cluster. So you get, when they say two, it's because we are getting our application, okay? For example, like an e-commerce app, and we give it to the cluster, okay, to manage it for us, okay? So when we deploy to Minikube, then they're saying run the app, then view application logs, okay? Then it looks like we have a prerequisite. They're saying this tutorial assumes you have already set up Minikube, okay? But we have not set up Minikube yet, okay? So let us what? Set up Minikube. They're saying see step 1 in Minikube start for installations. Okay, guys, it is very important that by the time you come here, you have understood all the previous, can I call them 7 videos that we have done. Very important. Okay, I've been seeing online people talking about, oh, Kubernetes is very hard. Kubernetes is very hard, but I've discovered from less learning like this, okay, that there's actually nothing really hard. If you take the time to read and reread, take note that actually even after these sessions, okay, I always take time to read again the documentation. Okay, I read it and it does not hard. That's how you achieve mastery, by doing something again and again. Okay, so if this is your first time watching, go along and watch along and read those pages again. Okay, the more we read and practice, that's how we achieve mastery. Okay, like I'm now seeing everything very simple. I wonder why guys complain about it being hard. And when I'm done with all this, I'm going to apply it to the flight booking engine. Then I'll create like one master video breaking down the concepts of Kubernetes end to end. Okay, and just to let you know, very soon I'm also going to make a video on Docker. Okay, so end to end for you to know everything that you need to know concerning Docker. So let us say they say sys step 1 in Minikube start for installation instructions. Okay. Then they're saying, so let us go to this page to install Minikube. Okay. They're saying look at step 1. I'll zoom in here. So what is step 1 is installation. They're saying click on the buttons that describe your target platform. For other architectures, see the release page for a complete list of Minikube binaries. Okay, so you can see this is step 1, okay, the step 2, step 3, etc. But what we're interested in right now, okay, so you see this is the Minikube documentation. What we're interested in here right now is only step 1. Okay, remember here what they told us. They told us to look at step 1. So I'm also going to focus on step 1. So if you're on Linux, click Linux. Okay, for me, you see I'm on Mac OS. Okay, I'm on Mac OS. Okay, and I'm on ARM. Okay, so if you're on Windows, choose Windows. Okay, if you're on Linux, choose Linux. Okay, so I'm on Mac OS architecture. I've chosen ARM. Okay, then they say installer type. Okay, I can use a binary download or I can use Homebrew. Okay, for example, they're saying to install the latest Minikube stable release on ARM macOS using Homebrew. Okay, so they say if I have Homebrew installed, okay, I can simply say brew install Minikube. Okay, then they're saying if Minikube fails after installation via Homebrew, you have to remove the old Minikube links and link the newly installed library, something like this. Okay, or they say I can use this command using the binary download. Okay, I curl, okay, and say sudo install Minikube. Okay, either way it works. Okay, that's the goal. Let me use this one. Okay, so I'll copy this command. Okay, open my terminal. I'm very excited. We're now into cool stuff. Okay, I'll make this terminal bigger. If you cannot see my terminal, please let me know. Right now, I'm trying to share my terminal. If you cannot see it, let me know. So let me confirm on this other screen if you can see my terminal. All right, I can see it. So I'll paste that command. Okay, then hit enter. Okay, and wait for it to install. So you see, following documentation is not as hard as people make it to be. Okay, you can learn from documentation and actually enjoy learning from documentation. Some of you who are, if you're new to this channel, about 1.5 months ago, I learned Fast API from the documentation from scratch over 31 days. If you're interested, you can find out that. And after that, I began building a project, a flight booking engine. And this project covers the front end, the back end, the DevOps. It's going to have AI integrations, so many things. And right now, I'm now focusing on the front end and back end integration. I've done DevOps concerning tools like Docker. I've used AWS EC2. I've used Terraform for infrastructure. I've used GitHub and GitHub Actions. Yeah, a lot has been done. So if you're interested and you want to learn, okay, and build something with me, yeah, that is something that you can do. So yeah, we are moving somewhere. Looks like, yeah, the installing takes time. Okay, but I guess either way can work, either using Homebrew or the binary download. Okay, I went with either way. So different ways. Where I come from, they say there are different ways of killing a goat. Okay, you can either strangle it, okay, or cut it with a knife, okay, or use a machete or a panga to knock it down. Either way, it works. So here we go. Here we go. Wow, it's taking some time. Teaching me patience. Okay. Wow. Let's wait for it. The advantage of recording videos is that when it takes long like this, you simply you can actually cut you and edit the video to make it shorter. But in live stream, you can't. Okay. You have to just wait it out. And everybody who is watching has to, of course, also go through it together with you. So let's go through it together and wait for this to get done. Shiasina. Thank you for joining. Is that how you pronounce your name? Thank you for joining right now. Is that how you pronounce your name? You say, can you please give a recap? Yes, I can give a recap. Like, do you need a recap of this particular session or a recap for everything we have been doing since the beginning, since day one? I can start by giving a recap for today. So today, the goal is to create our first cluster using a tool called Minikube. Okay. So over the past 7 days, that was last week. Okay. Today's day 8. We began day 8 today. We've been learning Kubernetes from scratch. Okay. Using the documentation. And this is the second time I'm learning something from scratch. So this is what happened. Okay. We went through a documentation. Okay. Let me show you the page. Okay. I think this page that says Hello Minikube. Okay. Is where we are right now. Okay. Here. But before it, there's a page I showed the viewers, which is this page which says walk through the basics. Okay. Walk through the basics has certain parts. So I discovered it by just skimming through. It has this part 1, it has part 2, 3, 4, all this. Okay. And all this we're going to go through them. Okay. So when I clicked part 1, okay, I saw that this part 1 links to down here. You see it says tutorial Hello Minikube. So it links to this. Okay, so in this stream today, we began by walking through this one here. Okay, and this one here was an overview, okay, or a re-explanation of what we said, I think, between day 1 and day 7. Okay, they talked about what a cluster is. Okay, and we discovered that a cluster is simply a group of machines that work together. Okay, a group of machines. It could be virtual machines or physical machines. They are connected together to work as a single unit. Okay, so a group of machines working together as a single unit is what a cluster is. Okay, then these clusters, which are single machines, have what is called nodes. Okay, I mean the machines are the nodes. These machines, okay, are called actually nodes. Okay, but these machines are managed by something called the control plane. The control plane is responsible for scheduling, okay, maintaining the desired state, okay, rolling out updates, okay, as simple as that. That is what they are all about. Okay, and then these nodes have something called a kubelet, okay, which is responsible for managing the individual machine, okay, and communicating with the control plane. Okay, so if you see the diagram here, okay, we have the clusters and nodes. So think of a node as a a machine, okay, a physical machine or a virtual machine, okay, and this control plane manages everything here, okay. But each node has something called a kubelet, which is responsible for communicating with the control plane. So communication goes between a node and a control plane. Okay, so the kubelet of a particular node talks with the control plane, and this happens via the API server. So the control plane has what is called an API server. Okay, so this is what this page is all about. Okay, and they said for us to create a cluster on our machine, we need to use Minikube. Okay, this Minikube is available for Linux, Mac OS, and Windows. Okay, so the next page here where we are right now is to help us run a sample app on Kubernetes using Minikube. So Minikube is going to help us create that cluster. Okay, so here you see they say that it helps us create what is that statement? Says it helps us to create a simple cluster. Says a simple cluster with only one node. Okay, as we're beginners, so it is a start for us. Okay, and so we're now on step 1. They're saying before we begin, this tutorial assumes that we have set up Minikube, but we have not set up Minikube. So I went to step 1. Okay, it says see step 1 in Minikube, start for installation instructions. So I came here, okay, and I was telling everybody here to choose their operating system, their architecture. So mine is Mac OS, ARM, okay, and I have 2 options. I can use either homebrew or the binary, okay. So I copied this command and I pasted it. I think it is now done. Next up, I have to copy now this other second command, okay, and I come here, okay, and I hit paste it and hit enter. I hope this has been a good recap for you. Okay, so you see it is asking me for my password. So I'll enter the password and it's done. There we are. it's done installing. Okay. So either Homebrew or this would have worked. If you're on Windows, do this. Okay. If you're on Linux, use this and choose your desired architecture. Okay. And what to use for installing. Okay. So like on Windows, you can use the .exe download, Windows Package Manager, Chocolatey. Okay. I hope this has been a good, it's been a good recap for you and you've understood. Okay. So I have installed Minikube. Okay. What is Minikube, friends? Okay. Minikube is a lightweight implementation of Kubernetes. Okay. Actually, I like the word. The word says mini. Okay. Mini. So something mini, something small, lightweight. Cube for Kubernetes. So Minikube, a lightweight. Okay. That creates a VM on our machine. So let's continue. All right. Yeah, I'm glad that it's made sense to you. So they say you also need kubectl. They are saying C install tools for installation instructions. Okay. So before we come here to create our Minikube cluster, okay, we need to see the install tools. Okay. So I'll remove this. Okay. Wait. Let me click on this again to make sure I've not gotten lost. Okay. They're saying install tools. So they're saying install kubectl on Linux, install kubectl on macOS, install kubectl on Windows. My friends, choose the platform for you. Okay. So that's why it's important to read. Okay. So I am on macOS. I'll click on macOS. Okay. So for macOS, they have options. Okay. So look at this. They say you must use kubectl version that is within one minor version difference of your cluster. For example, v1.34 can communicate with v blah 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 control planes. Okay, let us what install. Okay, they say install kubectl on macOS. I can use the binary. Okay, with curl. I can use Homebrew. I can use macports. Then there's verify. Then there's optional blah blah blah. Okay, so they're saying install kubectl binary with curl on macOS. Okay, so if you're on a Mac with Intel, use this. Okay, if you're an Apple Silicon, okay, use this. Okay, so they're saying to download a specific version, do this. Okay, but I don't know about the specific version, so I'll just copy this. Okay, I'll copy and paste. Give it time. Okay, so after that we can now, they're saying you can validate. Okay, just like you see, you install. Okay, even Homebrew is there. Okay, actually Homebrew is even easy. Okay, I guess I just wanted to go the hard way, to choose pain. I'll choose suffering. Okay, but I can simply would have just used one command: brew install kubectl. Okay, and I would be done. But I guess either way, it doesn't maybe shorten the process. Okay, it would still take some time because I'm sure, Homebrew under the hood would have to use what is it called? Would have to use um, curl commands. Okay, and make requests on its own. So let us go back to documentation. Where is this? I chose this curl with macOS, Apple Silicon. To download a specific version, I don't need a specific version. Then they're saying validate. I think it's optional. Okay, let us validate. Okay. I don't think it will hurt to validate the installation. Okay. Then after that, they're saying validate the cube against checksum file. We copy this. Okay. Paste. So they're saying kubectl awk. Okay. Okay. So they're saying valid output is that. Yeah. Why am I celebrating, guys? Yeah, I'm happy. I like it so much when I follow documentation, okay, and things are just working. If you've been a developer for some time, you know that it's not obvious that things are going to just work. sometimes you can actually cry a little bit and have tears. But seeing this, okay, makes me very happy. Okay. Then they're saying if you check some fails, you'll get something like this. Okay. Okay. Looks like we have other steps. Let me first read up here. Verify. Let me say verify. Looks like we're not done with the installation. Okay. So let me do this. Where are we? We're following this. Okay. We verified the checksum. What else do we need to do? They say download the same version, blah, blah, blah. They say make the kubectl executable. Okay. I'll copy this. Okay. Again, if you don't know Linux commands, this thing can be confusing. Okay. But one time I'll make, I think, a complete video on Linux commands. But this, when you understand it, is very simple. Okay. But it's simply making it executable. Then they say move the kubectl binary file to a location on your system path. So maybe I'll copy this, paste, enter my password. Okay. Then do this. Done. Okay. And they're saying make sure your local bin is in your path environment variable to ensure that your version is installed is this. I copy this. I'm starting to think if I had used Homebrew will do this for me. Okay. So I accept I've been foolish to go the long route. Okay. So see the client version, customized version. So we are done with that. Then they're saying all this, but I'll leave that. So after installing after installing and validating kubectl, delete the checksum file. Okay. So this is an other alternative for checking this version, but I don't need to do it. So I'll copy this. Okay. Delete the checksum. Okay. So you see if we had used Homebrew, okay, are you seeing how easy it is? Okay. You just say brew install kubectl, and we don't have to go through all those steps. Okay. It's very short. So my friends, make sure if you're on Mac, use Homebrew. Okay. If you're on Mac, use Homebrew to make life easy for you. Okay. But again, if of course on other operating systems, use your required operating system. So what else do we need to do? We're done with installation, maybe verifying. Okay. We can copy this command. Okay. And paste. Okay. So they're saying if you see a URL response, kubectl is correctly configured to access your cluster. If you see a message similar to the following, kubectl is not configured correctly or is not able to connect to a Kubernetes cluster. The connection to the server, blah, blah, was refused. Did you specify the host port? Okay, this is it. Okay. So it means kubectl is not configured correctly or is not able to connect to a cluster. So we need to create the cluster first. Okay. Which is fair enough. Okay. At least we know that the installation has worked. So we're done with installing. Okay. We're installed. So we need to create a Minikube cluster. Okay. So it is okay for us to have this message. Why is it okay for us to have the message? Because we haven't created the cluster yet. Okay. We have simply followed the instructions. So guys, do not miss a step. Okay. Just follow the documentation, just like I've been following. Okay. And all will be well. So I can now go back here and I say, copy this command. Okay. Minikube start. So let me clear my terminal. Okay. Clear the terminal, paste, hit enter. Okay, so it says Minikube, okay, Darwin automatically pulling a Docker image. Okay. Again, if you don't know what Docker is, I'll explain to you one day. Let's see some magic. Aren't these the screens we see in movies? Crazy. Okay. Guys, if you're watching and you have a connection to Hollywood, take a screenshot of this and send it to them. Tell them you can use this for the next hacker movie. This is a guy hacking the CIA. Okay, let's give it some patience. Yeah, and actually, Yeah. So the next step is opening the dashboard, but you cannot open the dashboard until the Minikube start is done. So yeah, if you've been learning with me and you think what we are doing here is very interesting, go ahead and share it with your friends in your community. I want to start a Discord so that it's easy, like to maybe answer questions. Many times I've begun receiving questions via email. But I feel like if I had one place where I answer questions and anybody else asked a similar question, I would point them to a solution. And then also other people can contribute to the same thing. Because you might find we have people who have more experience than I. Okay. And I can benefit from them. Even those who have less experience than me I can still benefit from them. You can also benefit from them. Okay. Because someone can have less experience than you, but they know something something niche that you do not know. Okay. Okay. So it looks like a lot of data is still being downloaded. Wow. These things need data. Okay. So if I think if you don't load enough bundles, it can easily frustrate you. But let's be patient. Okay. For this cluster to be created. It's interesting how being consistent can actually help you. Okay. Can you believe these are 8 days since we began learning Kubernetes? Okay. Began with the theory, we understood the theory, and now we are very close. Okay. 8 days of consistent learning. And tomorrow, okay, we'll be here. Okay. The next day, like that, like that. Before you know it, we've made up a month. Wow, it's taking some time. I think this is normal, especially the fact that it's now it has to download certain things. Okay. Actually, the commands are not that many. Okay. There are lots of things, just a few things I've seen here. So what is slowing us down is just the internet. Okay. My internet speed. But yeah, we're getting somewhere. I'm seeing so many things having like about 450 MBs. 450, somehow 332. Okay, it's actually either 450 or 332 MBs. There's something called preloaded images, K8s V1, okay, being got this one here. Preloaded images, K8s V1. Then there's this gcr.io/K8s Minikube, KIC base. Yeah, those are the only two things I'm seeing. These preloaded images, then the gcr.io. This preloaded is about, I see here 230, no, it is 332. Okay. And this one here, the GCR is 450 MB. Okay. So here I see they say 69 out of 450. For this one, 235 out of this. Let us scroll and see. How far? Okay. It has moved. For the one of 450, now I'm seeing 89. For the one of 332, I'm seeing 287. Yeah. Can I call it? Yeah, it's almost. So if I control scrolling, so the one of 450 is at 93. The one of 332 is now at 308. This one is almost done. The preloaded is almost done. Okay, so I guess when this one here gets done, so you actually can see it's 96%, this one is 21%. Okay, yeah, so the other one is done. So we have only one now going. This one is actually now faster. Okay, given that it's the only one. So you can see it's loading faster now because it's now the only one being loaded. So guys, if you're enjoying this, yeah, hit that like button and subscribe. Let's be the community. I'm thinking of creating a Discord community. I don't know what you think about that. And I would need help, of course, from you. Like people to like manage that community and stuff like that. And of course, in the long run, whoever manages the community has to be paid. Okay? Because it's now working on only one, it's now getting, looks like it's downloading about 1.2 MB per second. 1.2 MB per second. You see this bottom left corner, 1.3, now so 1.3 MBs, I think, per second. Now we're at 180, about 180, 100 out of 450 MBs. This is about 40%. Yeah. What's the best way of learning? To be patient. Waiting for an installation and a download on a live stream. I don't know if there's any better way of learning. Of being taught patience or learning patience. Where you have to sit and wait it out until you're actually successful. But we're close. Let me see how much time has been spent. About 48 minutes. I usually want these morning sessions of mine to last an hour, but we are actually getting there. So we have about 50%, okay, 59. We are close to 60% of this GCR, whatever it is, should be really pretty important with a lot of stuff. That is why, as a software developer, one of the best things you can invest in is fairly enough storage and fairly enough memory. Okay, I think in our age, if you have memory of around 16 GB and storage of around 500 GB, yeah, you can start, or 500 GB SSD and maybe 8 GB. Let's say 16, okay? Because sometimes back then 8 GB would look like the basic minimum. But the way I see these tools, how they are and how they work, it appears having 8 GB. I mean 8 GB, yeah, having 8 GB is like small, maybe 16. But of course you can even manage with the 8. But you'd have to close other applications, okay? Like here, I think I have other applications running. Like I have VS Code, I have Postman, even Docker itself is running. You have a browser. This browser has a number of tabs, okay? But not so many tabs. I don't know how many tabs these are. 1, 2, 3, 4, maybe about 20 tabs, okay? But again, I wouldn't expect all of them to run because I think Chrome has this thing whereby it's like, can I call it deactivating, or makes like an inactive tab to sleep? We're at 80% friends, okay? 80%. So you can see, yeah, 89, 90%, about 400. We're somewhere, okay? 93%. Hey, Big Chill. How are you doing? Thank you for joining today's stream. I hope you're getting something out of this. How are you today? Okay, 100%. So it should be anytime from now, I should get something, some confirmation. Would you like to access? Let me just say allow. What do you mean? What do you do, man? I'm a full stack software engineer. Yeah, that's what I do for. Tell me something about you. Yeah, I'm a software engineer, a full stack software engineer, but I love working on the back end. Okay, I've worked in in several industries. Okay, my first experience, I worked in the health sector. Okay, where I participated in building a full stack application for hospitals in my country, and we used Spring Boot for that. Okay, we used Spring Boot. Spring Boot is a framework of the Java programming language. So I worked on because this whole system had so many departments. Okay, and I worked particularly on the module for the laboratory. Okay, that was my very first experience in tech. Okay, and we built on a team of about 5 people. We worked on the lab. Okay, and yeah, we built it using Java. So it was Java Spring Boot. Okay, Java the programming language, Spring Boot the framework, Bootstrap, jQuery. Okay, after that, I had another experience working in the law sector where we're building a chatbot for lawyers. Okay, in Congo and Uganda. And there I worked as also a full stack developer, but mainly on the backend. I didn't do any front end work. I only did backend work. In that time, we're building an API, both a REST API and a GraphQL API, but we're using Node.js. Okay, using Node.js and yeah, Express.js, Node.js, basically that. But it was a bot, an API powering a bot, a Facebook bot. After that, I moved. I have also worked for a company in Nigeria. Okay, where we're using Django. Okay, I built an entire self-service system, okay, for a company in Nigeria called Utopia. Complete self-service. So the tech stack, I used Django, I used AWS EC2, I used there's an API, we integrated Paystack for payment. This is the first time I learned about a payment gateway called Paystack, founded I think in Nigeria by Nigerians. What else? Yeah, Bootstrap, some JavaScript for the Django templates. Yeah, that was it. Then I've also, yeah, number of things. And currently, yeah, I'm now doing so many things. I freelance. I've created many projects. Right now, I'm creating an asset management tool for a client in Ghana, and I'm also a technical mentor at ALX. Okay, I've worked this year with some clients in Uganda. There's a guy who has a farm. Okay, client has a farm in the eastern region of Uganda. They have a coffee farm, and I worked on their website, and I'm working still on their system. Okay, and here on YouTube, I'm now expanding my knowledge. Okay, by learning DevOps. Okay, learning DevOps and building a full stack application back to end to end. Okay. Last month, I spent about 30 days, I think 2 months ago, 30 days on YouTube learning Fast API. After learning Fast API, I went on to start building this project. Okay. I built the project. I've done a lot of DevOps like AWS work, Docker Compose. I've done, what else have I done? Yeah, the backend is like 90% done. I've done integrations with an external API. We have worked with Redis, background tasks, emails. Now I'm doing now the front end integrations. Okay, and actually tonight I'll be resuming the front end integrations if possible. But that's what I want to do tonight. Continuing with the integration of the backend to the front end. So the front end is Next.js. Okay, yeah, maybe that's something else I forgot to tell you. Sometimes when I'm building front ends, I use Next.js, but I really love the backend. Okay, I would rather work on the backend than the front end. I do full stack projects if it's very interesting and worth it. Okay, and right now you see me learning Kubernetes. Okay, learning DevOps. I will also apply it to that project and also projects of my clients and stuff like that. Okay, yeah, that is like a summary of what is about me. I hope I've answered that question when you said I should tell you something about me. So that's what I can say about me for now, like shortly. But yeah, there are things that I can tell you maybe off here. All right. So, guys, looks like we have some success. Okay. Says creating Docker container. Says done. kubectl is now configured to use Minikube cluster and default namespace by default. Okay. Big Chill says awesome. Thank you. You could also maybe tell me about who you are, what you've done. Okay. I'll be interested. Of course, since you're texting, you don't have to overtype. I'll be interested to also know something about you. Okay. You can please type it in the chat. So let's go on. Okay. So we are done with creating a Minikube cluster. Okay. That has been successful. And if you're just joining right now, we ran the command minikube start, okay, which took some time and tested my patience. But yeah, here I am. I've been patient, or rather, we have been patient, not I, but we. Okay. So let's go on to the next title. It says open the dashboard. They're saying open the Kubernetes dashboard. You can do this in two different ways. Say launch browser or URL copy and paste. Okay. So launch browser, you're saying open a new terminal and run Minikube dashboard. They're saying now switch back to the terminal where you run Minikube start. Okay. So let's go step by step. Okay. So I'll copy this command. Okay. I've copied the command and they're saying open a new terminal. Okay. So it's important to follow instructions. So how do I create a new terminal? If I go to view, is it in edit window? New window. Yeah, it is shell, new window. Okay. So here's the new terminal. So let me also expand it so that you can see. Okay. Then I paste that command, minikube dashboard. Okay. Excuse me. So it says enabling dashboard. Okay. So they're saying now switch back to the terminal where you run minikube start. Okay. So if I switch back, okay, I've switched back. Then they're saying, let us read this note. They're saying not. The dashboard command enables the dashboard add-on and opens the proxy in the default web server. Okay. You can create Kubernetes resources on the dashboard, such as deployment and service. To find out how to avoid directly invoking the browser from the terminal and get a URL for the dashboard web view, see the URL copy and paste tab, which is this one. Okay. But we shall go to it. Let us follow and read. Okay. I love reading everything. By default, the dashboard is only accessible from within the internal Kubernetes virtual network. The dashboard command creates a temporary proxy to make the dashboard accessible from outside the Kubernetes virtual network. So they're saying what we have created so far here, okay, is only accessible from within, okay, the Kubernetes internal network. But using Kubernetes dashboard command makes a proxy for us to enable us access it on our browser, okay. So they're saying to stop the proxy, run. What's this? What have I clicked on? They're saying, come on, okay, it's here. To stop the proxy, run Ctrl+C to exit the process. Okay. After the command exits, the dashboard remains running in the Kubernetes cluster. You can run the dashboard command again to create another proxy to access the dashboard. So the dashboard remains running within the cluster. Okay, because the cluster is like isolated, it's like something independent. Okay, so to access it, we need a connection to it. So this proxy is the connection to it. Okay, so Big Chill says, so currently I'm doing computer science in India. I learned HTML, CSS, JS, and React, and now I'm starting to learn backend. But my friends are telling me to do DSA for placement fast. Now, your friends could be right, okay? Because we have different knowledge and different experiences. But this is what I will tell you, Big Chill, in my opinion, okay? Since you've learned HTML, CSS, JavaScript, and React, okay? Build 2 solid projects using that stack. That is the front-end stack, okay? Build 2 solid projects using HTML, CSS, and React, okay? One of those projects, use an external API, okay? Then Google for React best practices on GitHub on the internet, okay, and apply them to them, okay. Then again, I would suggest that you either migrate one of those projects or build a third project using Next.js, okay. After you've built those 2 solid projects and you have migrated one of them to Next.js, or you've built a third project using Next.js, start DSA. Okay, start DSA while you improve your those projects. Okay, and heavily network. Okay, heavily network. In fact, start networking even now and share your progress on the internet, like on X, on LinkedIn. Okay, that's how I would suggest. Okay, don't stop. First build a project. Since you've learned HTML, JS, and React, build a solid project using it. Okay, that's what I would suggest. All right, guys, let's continue. Okay. Okay, so this is the first way. Okay, I want to put these terminals side by side. So this is it, okay? So the thing we can open this here to find it, okay? So, let's look at the second way. So the second way URL and say if you don't want if you don't want Minikube to open a web browser for you, okay, run the dashboard command, run the dashboard subcommand with the URL flag. Minikube outputs a URL that you can open the browser you prefer. Okay, they're saying open a new terminal and run Minikube dashboard minus URL. They're saying now you can use this URL to switch back. You can use this URL and switch back to the terminal where you run Minikube start. Okay, so I can do that. Okay, I can close this. Control C to close this one. Then I close it. Okay, then I run this command Minikube dashboard minus URL in a new terminal. So I'll come to shell, new window. Okay, I'll drag it on the left here, expand it so you can also see it clearly. Okay, then paste, okay, that command. So let me drag it so you can see it clearly. Okay, so you can see it's Minikube dashboard minus URL. Hit enter. Okay, so they're saying, wait, they say if you want, I want to read this again to make sure I've understood. They say if you don't want Minikube to open a new browser, if you don't want Minikube to open a web browser for you, run the dashboard subcommand with the URL flag. Minikube outputs a URL that you can open in the browser you prefer. Open a new terminal and run. Now use this URL to switch back to the terminal where you run Minikube start. Okay, they say now use this URL and switch back to the terminal where you run Minikube start. Okay, I've understood. So I'll copy this URL. Okay, go to my browser. I'll open a new tab and paste. Okay, here we are. Okay, so you're saying there's nothing here to display. And if I go back to the previous tab, yeah, it is here. Okay, I see, my friends, nothing hard. Big Chill says thanks. Yeah, I am glad that you have been helpful to you, Big Chill. So guys, I think the myth that following documentation is hard is a lie. Okay, so yeah, look at. So this is a simple dashboard. Okay, I like what we have so far. Okay, I'm missing your namespaces. I don't know what this is. Okay, but yeah, we are learning. Isn't this good success? So if you're enjoying this, please, like I say, like this video, subscribe, and let's build a community, and yeah, share it. Share this with your friends in your network, so we can grow this and make it stronger. Okay. All right, let's continue. Again, I see I'm past time by 5 minutes, but let's try to wrap up. Okay. What took long was the installation. So they're saying create a deployment. Okay. Now they're saying Kubernetes. A Kubernetes pod is a group of one or more containers tied together for the purposes of administration and networking. Okay, friends, we're now going deeper, okay, into the cluster. A Kubernetes pod is a group of one or more containers tied together for the purposes of administration and networking. So they say the pod in this tutorial has only one container. Okay, but it can be one or more. Then they say a Kubernetes deployment checks on the health of your pod and restarts the pod's container if it terminates, helping us to be fault tolerant, okay, fail safe. They say deployments are the recommended way to manage the creation and scaling of pods. What is a pod? A pod simply means many containers, a group of many containers. And these pods, remember, work in the node. Okay, the node is the machine. Okay, so this machine has containers, a group of containers running. And this group of containers are called a pod. But it can be one or more containers, or it can be one container or more than one. This is how I understand these things. Okay. Maybe a node, okay, which is a machine. A group of these nodes, and nodes are machines, are called a cluster. Each of these machines have pods. These pods are simply a group of one or more containers. Okay. And a Kubernetes deployment checks on the health of our pod. Okay. If this pod is working correctly, okay, it chills. Okay. But if there's an issue, it restarts it. Okay. And they're saying a deployment is a recommended way to create the pods and scale them. Let's now continue. Okay. They are now saying use kubectl create command. Okay. Use the kubectl create command to create a deployment that manages a pod. The pod runs a container based on the provided Docker image. That's why last time I was saying it is important to know Docker, okay, before you come to Kubernetes, okay. But if you don't know Docker, I feel like you can still understand the concepts, okay. If you don't, you can maybe search the internet or YouTube for a Docker video and you watch, okay. But I plan on doing a video that either one video, a series of video that explain everything you need to know concerning Docker, okay. So that will come up very soon. So you're saying use the kubectl create command to create a deployment that manages a pod. The pod runs a container based on the provided Docker image. Okay. So a container is simply a running image. Okay. So we're going to use kubectl create to create a deployment. Okay. And a deployment manages a pod. So they're saying you have this command. It says kubectl create deployment hello node. Then they say minus image. This is the image. Okay. This is the link to the image in the registry. Okay. Like that. Then they have other arguments. Okay. There is net execute. And then we are seeing a port running on port 8080. Okay. We don't have, excuse me. Let me just get a glass of water. I'll be back. Now, one thing I see people making on the internet, a mistake is trying to cram these commands. I'll never cram these commands. Whenever I need them, I'll use them. Okay, I'll simply Google them and use them. Okay. So I'll simply copy this command. Okay. At least what I know is that kubectl create is for creating a deployment. Okay. And deployment must be a keyword. And this should be the name of the deployment. So I'll copy this. Okay. Come here. I'm sure later it will explain. Okay. Come here. Paste. Okay. The command and hit enter. I see in this, it's saying deployment.apps hello node created. Okay. This makes me to know that hello node is the name of the deployment. Okay. Then we can now use this command saying kubectl get deployments. Okay. So kubectl get deployments. Okay. And this is me now trying to code it, to write it from scratch without pasting. And I've been successful. Okay. Sometimes it's good to type out the commands, maybe to reinforce the learning. Okay. So this is the hello node that we created. Okay. So at least we know that kubectl, there are two commands. Okay. This is how I like summarizing it. Okay. There are two commands. Okay. We have kubectl create deployment for creating a deployment. Then we have kubectl get deployments for seeing the deployments, to view or see the deployments that we have. Okay. Then when you're creating a deployment, you specify the name of the deployment, like hello node is the name of the deployment. Then we specify the image using minus image. Okay. Then we specify like the port using like minus HTTP port. This is how I understand them. Eugene says, I have tried running Minikube in my machine. Let us just say I need desktop workstation with at least 16 GB RAM. Yeah, Eugene, it can be really, really bullying. It can bully you at some point. Okay. Yeah, you try this. The 16 GB should work because actually on this machine I also have 16 GB. So it should work on your machine too. Good luck with that. Or you can actually what you can do, Eugene, this is another idea. You go to AWS, okay? Try to create a free tier account, okay? Then use like a Ubuntu machine, an EC2 Amazon machine image for EC2, okay? And run Ubuntu 20 or any latest version of Ubuntu, or even Mac, okay? But do it on Ubuntu. And then you can practice these things for free there. Yeah, sorry about your limitation, but yeah, you can work around it. Okay. So since it may take some time for the pod to become available, if you see 0, 1, try again in a few seconds. Let us see what we have. Okay, we have 0, 1. So, hey, oh, now I get it. We have, this means, no, okay, now I get it. I get it. I think it's supposed to be 1, 1, okay? But if it's 0, 1, it means the pod is not yet available. Okay, this makes sense. I get it. So I have to, I can now do, I can now what? I can what? I can do it again, okay? Do the command kubectl get deployments, hits, you see it is now 1, 1. Okay, so they say, if you see 0, 1 like me, be patient, then wait for it, okay? Let me expand this so that you can see it in one line, okay? So I think, let me clear the screen, okay? Clear the screen, get deployments, kubectl get deployments, that's our deployment hello node, okay? Then we can now say kubectl get pods, okay? Kubectl, let's remove this word deployments and say pods, okay? What is a pod? A pod is a group of one or more containers. Simple. What is a container? A running image. What is an image? An image is simply a bundle. It's simply our application code and its required dependencies. Simple as that. Okay. I plan to explain all the things sometime in one video after we have learned all this. But it's pretty interesting. So there we have our pod, okay? And you see the output is similar to this, yeah? You see it's the same thing. We have the name, ready, status, restarts, edge, okay? If you make it wider, you see? All these columns, we have them right here, okay? So I'll scroll. They're saying view the kubectl configuration. So I can say kubectl view config. Is it config or configs? Oh my God, I switched them. Kubectl config view. Okay, and there we are. You see, this is the configuration. And look at this. Look at what is interesting here. They say users name Minikube. Isn't this interesting? All right, let's continue. They say view application logs for a container in a pod. Replace pod name with the one you got from kubectl get pods. Okay, they're saying not replace hello node with this gibberish in kubectl logs command with the name of the pod from the kubectl get pods command output. Okay, so we're going to say kubectl, then we put the name of the kubectl logs, then the name of the pod. Okay, so let me clear the screen first. Okay, so I'll first say kubectl get pods. Okay, then I copy this pod name. Okay, take note of it. After that, I can say kubectl, what's the command? Logs, kubectl space, logs, then I paste. Okay, hit enter. Okay, so you see it says started HTTP server on port 8080. Okay, started UDP server on port 8081. Those are the logs. And when that happened, the date and time. Isn't it cool, guys? So if you're enjoying this, smash that like button and share this with people in your network. Let's go on. Okay. You see the output is similar to this. Yeah. We got two servers. Okay. HTTP server and UDP server on these two ports. We're moving somewhere. The same for more information on kubectl commands. See the kubectl overview. I'm not going there. I'm a beginner. Let's learn first. Okay. Now there's say create a service. Okay. Now we have deployment. We had a deployment. Okay. And now we're going to creating a service. They're saying by default, by the guys, if this is confusing, so make sure you watch this video again and do it. Okay. Because me after this video, okay, later in the day when I'm resting, I'm going to read this documentation again and I'm going to practice everything again. Okay. So they're saying by default, the pod is only accessible by its internal IP address within the Kubernetes cluster. To make Hello Node, the Hello Node container accessible from outside the Kubernetes virtual network, you have to expose the Kubernetes, you have to expose the pod as a service. Read again. By default, the pod is only accessible by its internal address within the Kubernetes cluster. Which pod is that? This pod here. Okay, this is the pod name. And we know it by saying Kubernetes, kubectl get pods. Okay. And they're saying to make this Hello Node container accessible from outside the Kubernetes virtual network, we have to expose the pod as a Kubernetes service. Right now, it's just a deployment. We have deployed it, it's running. Okay. Think about a deployment as what? A running pod. Okay. But now it is only internal to Kubernetes. So they're saying for us for it to be exposed outside, we create a service. So a service exposes our container. Okay. Now they're saying warning. They're saying the ag host container has a /shell endpoint, which is useful for debugging, but dangerous to expose to the public internet. Do not run this on an interface facing cluster or a production cluster. Okay. And actually we did it. Let me show you that command. Okay. Now I'm now understanding what I like how they go back and explain to you something that you saw. Okay. Are you seeing this ag host container? Are you seeing this --/ ag host? Okay. It's what we added when we were creating the deployment. Okay. All right. Let's now continue. They're saying expose the pod to the public internet using the kubectl expose command. Okay. They're saying kubectl expose, okay, deployment. Remember, it's not create. So kubectl is a command. Expose is the keyword. Deployment is the keyword. Hello Node is the name of the pod. Okay. And then they're saying the type is load balancer and the port is port 880. So the goal again, my friends, is to understand. The goal is not to cram. Okay. So I'll copy this, paste it. Or maybe if I clear my screen, I can say clear. Okay. Then paste. So you're saying kubectl expose deployment hello node. Okay. She says service hello node exposed. So we have created a service. I think by saying actually type load balancer. Okay. This makes sense because actually a load balancer is supposed to pick traffic from the internet, okay, and distribute it evenly. Okay, isn't this awesome, guys? Now they're saying the type load balancer, the --/ type load balancer flag indicates that you want to expose your service outside of your cluster. Okay, we go on the next statement. We're almost done. It says the application code inside the test image only listens on TCP port 8080. If you used kubectl expose to expose a different port, clients could not connect to that other port. I want to read this again. And now you might have noticed I love reading things again and again to make sure I've understood them. They're saying the application code inside the test image only listens on TCP port 8080. Okay. That is okay. That is understood because of this. Okay. Now they're saying if you used kubectl expose to expose a different port, okay, like maybe port 8000, clients could not connect to that other port. Okay, so it only listens to port 8080. Okay, I think because of what we did up here, where is it? We defined it here in the when creating the deployment. Okay, I think this HTTP port 8080, so it has to only use that. Yeah, it makes sense. Makes sense. So let's go ahead. It says view the service you created. So kubectl gets services. Again, my friends, just understand these things. In my experience in software development, I've learned that there's no need to cram anything. Simply understand it. Okay. These commands, we shall master them when we do it again and again and again and again. Okay. So you can say cube, just copy it and paste to the services. Okay. There. So what can we, at least just know the concept that we can create a deployment. Okay. We can view deployments. We can view pods. We can create a service. We can view a service. We can view the application logs. Okay. So you see we have this. Okay. So they're saying the services we have type of load balancer, and then they're saying type cluster IP. So we have two services. Okay. At least we know what load balancer is. We know that type load balancer exposes the application to the external world on the internet. So they're saying on cloud providers that support load balances. Let me read this again. On cloud providers that support load balancers, an external IP address would be provisioned to access this service. On cloud providers that support load balancers, an external IP address would be provisioned to access the service. Okay, good to know. Actually, even on AWS, if you saw me, those who have been following me building the project in every evening, when we deployed to AC2 the first time with Docker, you saw that we had an external IP address that was given to us, I think, by EC2, the Elastic, the public IP address, if I'm not confusing. No, they're not the same. They're not the same, actually. They're different. Yeah, the concept is different. The other one, actually, on AWS, you'll have to go back in inbound rules and connect things. But here I'm seeing that we're just given an IP address. Okay. So how let me make sure, I want to make sure I've understood this. They're trying to say that if I was using something like AWS or GCP, I would be given an external IP address. All right. Got it. On Minikube, the load balancer type makes the service accessible through the Minikube service command. Okay, since we're not on Minikube, okay, through the Minikube service command. So I can say Minikube service hello node, okay, because if we check here, okay, we have a service called hello node, okay. So if I paste, okay, there we are, okay. I run it without being warned, okay. So they're saying this opens up a browser window that serves your app and shows the app's response. Okay. So you saw it opened up this. Okay. And this was the response we got. You can see the IP. Okay. And the port. Isn't that interesting, guys? Let me expand this for you to see. Okay. This is just exposing the current time. Okay. And if you look at this, okay, says namespace, the name, target port, to gives us the URL. Okay. So you see, internally, guys, this is interesting. So internally, it is port 80, okay? But it gives us something external, okay? With even a different port. So this is like the gateway to this, what is inside. And that's actually how I think a load balancer should work. No, this is actually the one which we are using, okay? This is the one, okay? Yeah. Thanks to me for guessing. We'll keep planning as we go on. So say starting internal for service hello node, opening service default in the default browser. Because you are using a Docker service on Darwin, the terminal needs to be open to run it. Okay. Okay, good to know. What is this? Let me reset. Oh, so you remember the dashboard that we ran? It's showing some metrics. We should have come here. Okay. See workload status. It says we have one deployment. We have one pod. There's one replica set. Interesting. Okay. Talks about the deployment created 16 minutes ago. The pods. Okay. I don't know what a replica set is, but I guess it should be like a copy. Okay. But we shall run. We shall run. Don't need to hassle. We shall learn all this soon. I love that. I love that the dashboard picked it up. Okay. Very, very nice. I'm very happy. Guys, this is the first day I've run things and they are working. No bug, no whatever. You should have seen when I was building the flight booking engine, the number of bugs I got were disheartening. Guys, I've noticed something. Has YouTube changed the design for you? I feel like the buttons of next have changed. I can't even see the subscribe button. Let me know if you can see the subscribe button, guys. It has changed somehow. I don't know if I can show you. It has changed. But let me not divert, okay? Sorry. Let's continue. They're saying enable add-ons. Okay, we're almost done. They say, I think we've been here for about 80 minutes. But it's good to learn, okay? It's been worth it. Sometimes you need to spare about 4 hours a day to focus learning, okay? Like this. So let's continue. So the Minikube tool includes a set of built-in add-ons that can be enabled, disabled, and opened in the local Kubernetes environment. Okay, so they say list the currently supported add-ons. Okay, so you can say Minikube add-ons list. I hope no one had forgotten about Minikube. I hope no one had forgotten about Minikube. Okay, so do I need a new? Should I create a new terminal or what? Okay, let me create a new terminal. It won't hurt. New window, so that I don't close everything else. Okay, expand this. Okay, so that you can see, and I paste. So Minikube. So these are the available add-ons that they have given us. Okay, I don't know what they are, but let's read on. Okay, they're saying the output is similar to this. Yeah, we get something like this. Okay, we get a number of add-ons. Okay, but I can just see. Yeah, okay, it's okay. Then they're saying enable an add-on. For example, metrics server. You can say Minikube add-ons enable metrics server. Okay, so I can copy this command. Okay, and maybe let me clear the screen. Okay, and paste. Okay, hit enter. Okay, they're saying metrics is an add-on maintained by Kubernetes. For concerns, contact Minikube on GitHub. Okay, they say you can view the list of Minikube maintainers at this URL using image registry, and they say the metrics add-on is enabled. Kubernetes is hard. Kubernetes is hard. I see nothing hard. Nothing hard, guys. What is hard about this? Sorry. Let's continue. Okay. They say output is similar to this. Okay. This is what we've actually seen. Okay. That the metrics server is enabled. Then they say view the pod and service you created by installing that add-on. Okay. So you're saying kubectl get pod. So this is how I understand. Minikube, remember, is for what creates the cluster. Kubectl is what we use for interaction. Okay. So I'll read this. Say view the pod and service you created by installing that add-on. So they say kubectl get pod. Okay. svc minus n kube system. Okay. I'm sure later on they're going to explain to us what this code, these commands really mean. Okay. But this get pod should make sense. Okay. This SV I'm starting to think is maybe service. Okay, but let's copy. Okay, let me not over speculate. Copy it. And why am I using the mouse for copying? Why can't I just do the keyboard stuff? Command C or Control C. So this is it. Okay, what did they say? They say view the pod and service you created by installing that add-on. Okay, so we created what means we created the pod and service. So an add-on has a pod and a service. Okay, the pod is the actual container. They say a pod is a one or more group of containers. Okay, then the service is what helps us to access it to the external world. Okay, so they automatically do the load balancer thing for us. So we have this core DNS, etc Minikube, API server, control manager, proxy, scheduler, matrix, storage provider. Okay, these are the pods. Okay, then for the services we have a cluster IP, cluster IP. There are two. There's the kube DNS, then is matrix server. So the output is similar to this. Yeah, and it's indeed similar. They say check out output from the matrix server. They say kubectl top pods. Okay, I can paste that, and there we are. Okay, we get similar output like that. Interesting. We are coming to the end. So if you see the following message, wait and try again. So if it's something like this, like error matrix API not available. Okay, so you see for my case it worked. Okay, it worked. If I clear the screen, okay, and I use that command, it worked. Okay, but I think if you see this message, be patient and try again. Okay, then they say we can now disable the matrix server. So I can copy that command. It says Minikube, okay, add-ons, disable matrix server. Okay, to enable, you just say enable. If you go up, okay, so at least I know that to enable, I say add-ons enable. To disable, I say add-ons disable, then the name of the add-on. That's how I understand this concept. If I forget, I'll simply Google it or come to documentation. All I know, what is important to know is that they're add-ons. Okay, and I can see a list of add-ons. How do I see a list of add-ons? I simply use this command, Minikube add-ons list. If I've forgotten, I simply Google it or check the documentation to find out how to list the available add-ons and then add the add-on which I want. Okay, very okay. So I can come here and paste that command. Says the matrix server add-on is disabled. Pretty easy, in my opinion. So they say the output is similar to this, which is okay. Now they're saying clean up. They're saying now you can clean up the resources you created in your cluster. Okay. They're saying kubectl delete service hello node. I'll copy this, come here, paste. You see, they're saying service hello node deleted from default namespace. So kubectl delete service hello node. So kubectl, okay, delete service hello node. Simple. Then after deleting the service, we delete the deployment. Actually, it makes sense. You cannot delete a deployment. You cannot delete I mean, like the order makes sense. That's what I'm trying to say. So paste, say deployment.apps hello node deleted from the default namespace. Okay. Then after that, stop the Minikube server. The mini server cluster. I'm so used to servers. Paste, saying stopping Minikube. I like the emoji. Powering off Minikube via SSH. Okay. Then they're saying optionally delete the Minikube VM. Okay, we can say Minikube delete, which is optional. I don't think I want to delete it. Do you remember this command up here? Let me show you. When we were starting, this Minikube start, it took some time, guys, to download those two services. There's one of 200 MBs and one of 400. Okay, I'm going to leave it for now. Okay, maybe later when I'm practicing, I'll delete it. Okay, and redo because I'm going to practice all this again. Make sure I understand. So in your free time, also make sure you practice this again, guys. Okay, so that tomorrow when we resume, okay, with the next topic, we are all on set. Okay, and we know what we are doing, so that we have a conversation. Okay, so you see, powering off Minikube SSH says one node stopped. We had actually one node, okay? They say if you want Minikube again if you want to use Minikube again to learn more about Kubernetes, you don't need to delete it. Exactly. That's my state. I don't want to delete it. Conclusion, okay? The page covered the basic aspects to get a Minikube cluster up and running. You are now ready to deploy applications. The basics aspects to get the Minikube cluster up and running is done. So we are now ready to deploy applications. My friends, let's meet tomorrow morning to learn about how to deploy applications. For those who have been following the playlist of building a flight booking engine, this evening we're going to meet again and let's work and build that flight booking engine together. Thank you for learning with me in the series, okay, of learning Kubernetes. This has been the most awesome, the best of the best. Again, if you like this, join the community by subscribing, share with your friends in your network, like it so that others can find it. When you like, YouTube knows that this is nice, okay? And people get to know. If you have any question, you leave it in the comments, okay? Let's meet in the next stream. Okay, for those who are learning with me, who are building with me the flight booking application, it will be today evening. For those those who are only learning Kubernetes with me, day 9 will be tomorrow. Bye for now and see you soon.